Hello guys, welcome back to my channel. Today is session 10 of machine learning for teams. Today I'm gonna talk about k-nearest. I'm gonna go through some theory first, and I do k-nearest manually, and then I'm gonna use a k-nearest algorithm. Then I'm gonna go through k-mean clustering. I'm gonna talk about the elbow method, and finally I'm gonna show you an assignment, an interesting assignment. Okay, let's get it started. Let's first talk about k-nearest. K-nearest is the supervised learning. So we already talked about supervised, difference between supervised and unsupervised learning. In KNN, we find the nearest point, and all points belong to the same class as the nearest point. Okay, and basically in KN we do two things. First, we find the nearest point, and then we assign the class of the point to the nearest point. Okay, so let me show you a picture. You will understand what I'm talking about. All right, here you can see I have black points and blue points, and I want to see the actually the red point belong to the blue points or the black points. Okay, so I'm gonna find the distance between the red point and the blue point, all the blue points and also all the black points, and see which one is nearest. And this this red point will belong to the same actually class. For example, here it's really close to this one, and it means it's belong to the blue class. All right, so and here, yeah, that's the theory. And let's go to some coding. You will understand what I'm talking about. So I'm gonna use loan data here. Okay, we have text, income, credit score, loan, DTI, employment status, and approval. Approval is for the target column, and the rest are features. Okay, so here I'm gonna check if I have any missing value. So we don't have any, and then then I'm gonna actually drop the text column, okay, because I don't need that for this purpose. I just drop it, and you see I don't have it here anymore. And also there is one more point here, so I'm gonna check the column's name and see we don't have it here anymore. And I'm gonna actually use the one hot encoding for this one, for employment status. So you can see it's categorical, it's not numerical, and computers not cannot understand the numerical. Okay, and it's by the way it's nominal, it's not ordinal. Okay, so for this purpose I prefer to use one hot encoding. Okay, so let's do it here. So here I have employment status employed and employment status unemployed. Okay, so and you can see they are kind of similar. For example, if the employment status employee is 1, the other one is 0, and if this one is 0, the other one is 1. So it means if you have one column, you can understand the other column as well. So they are kind of redundant. We don't need to have both of them. Okay. So first of all, let's concat it to and I think I did something wrong here, and it was because Yeah, I run it twice. All right. Okay. So now I have mm, both actually both columns and also the original columns. The original columns is employment status. So we don't need this one because we have these two columns instead of this. Okay, I'm gonna drop it and see we don't have it anymore here. And also I'm gonna drop one of these columns because they are both actually same. If you have one of them, you can guess the other one. Okay, we don't need both of them. So if we just run it, okay, see, we don't have it anymore. Okay, and there is one point here. Approval is also categorical, and for this one, so I can use another technique here. And before that, I'm gonna rename this actually this column to employee. Okay, it's easier for me. That's it. Otherwise, that's not gonna change anything. So I'm gonna use label encoder for approval, and you know the reason because I already talked about that in my video about the categorical data and other stuff. So you see, for approval, it's 0 and 1. Okay, we don't have anything else here. I mean, any categorical data. Okay, so here, first of all, I'm gonna find the distance between the points as I told you here. So I'm gonna find the distance between this one and all the points, and I'm gonna find the nearest one, and actually find the class of the nearest one. Okay, so here so you can see the distance. I just showed the five nearest one. Okay, this one is really near to my point, so it's the distance is less than other distance. It's 436 36, and for the others is much more than this. Okay, so the class or the target variable, target column for this one is 1. It means my column, my point will be 1 because my point is really close to this one. Okay, and this is the reason. And so I'm gonna drop the distance column and again because I don't need it, and I'm gonna do the same thing by using KNN. Okay, KNN library. So uh, here I just define the x and y, and I'm gonna split the data into train and test. So you know all of this stuff. And here again I'm gonna use KN classifier. I'm gonna show you that you will get the same result. Okay, and if you just evaluate the model, okay, great. And also you just need to check if what you get as a class. Okay, so Ken telling me it's approved. Okay, approved. If you check my last code, you can see for approve, I said print approve if the prediction is 1, and otherwise if prediction is 0, is you need to print rejected. So it means approve or class 1. And so earlier I told you by calculating the nearest distance, I got the same thing. Okay, the class, it was 1 for that one, and also I got 1 here by using KNN. Okay, and that's it. So as a last point, as I told you, I always check the overfitting. I just want to make sure that we don't face overfitting anymore. So it's not overfitting. For training it's 0.85. for test data is like 0.81. It's not absolutely, it's not actually overfitting. Okay, so let's go to k-mean clustering. Okay, k-mean clustering is an unsupervised learning algorithm. So what it means, we don't have actually target column, or we have it, but we don't use that. Okay, so it means k-mean means actually we group our data into k cluster based on similarity. Okay, so let's back to this one. So we have two clusters here. Why? Because they are clearly, there are, one of them is this one and the other one is this one. Okay, and there is a point here. So we need to actually calculate SSE. So SSE is this one. Actually, the every point here. So let me use some other color just to show you. So for example, here is centroid of this one, and that one is centroid of the other one. So we gonna, if we have two cluster here, one is this one and the other one is this one, so we will calculate the distance between each point to the mean, okay, or to the centroid, and we're gonna sum them up. And so if I want to say about this one, we're gonna sum them up for each cluster, and finally we're gonna use this summation. Actually, it's for example, if we have two cluster here, it means we will actually sum SSE E1 and SSE E2. Okay, like this one. This is the sum of the SSE E1, and this is SSE E2. Okay, why we're doing that? The reason is this. Let me show you. So we need to actually find the elbow method. Okay, the elbow here, elbow here is like this. So we're gonna have a reduction here. Okay, and just a little bit here, but after this point is not too much. I mean, it's slightly it's going down. Okay, gradually it's going down, and this is the, we call this point elbow. Okay, so the best number for k is elbow. Okay, the the best number here is 3. Actually, the number 3 is the elbow, and here is something like this one. This is the elbow. Okay, because after this point it's decrease slowly. Okay, and this is the reason. And I'm gonna show you in code, actually encoding part. So first of all, for k-mean I'm using seed database, and just a different one. And you see we have bunch of feature and also a target variable. So we're not gonna use the target here. Okay, I told you, because we don't need that. We just want to classify our rows. Okay, or our records based on that. So uh, as I told you, so it's better to use a standard scaler. The reason is we gonna actually bring all the features into the same scale. Okay, and if you don't know, I already talked about a standard scaler earlier. Okay, just check the previous video. Okay, for here, I'm gonna go through number k number 1 to 20. Okay, to see which one is good for me. All right, and here again. So see this picture. So for this one, we have a big reduction here. So this is not the point, this one is the point. Okay, because after this point everything reduce slowly. Okay, but this one is so important. So after this point it's not important, because after this point it's not actually sse not gonna reduce too much. Okay, and this is the elbow. This is the best point for us if we want to use it for actually uh, for k-mean clustering. Okay, you can find it easily. And also let me back to presentation. So I have an assignment for you guys, and this is the assignment. So load mall customers.csv. I have it in my data set. I'm gonna show you. I'm gonna give it to you guys, and I want you guys apply k-mean clustering first and find the optimal k value. Okay. Then I want you use KNN to do some prediction, okay, like what we did earlier. And finally, this one is really important. So for hyperparameter tuning, like something that we have done earlier, okay, in last session. So I want you guys use grid search cv and find the best actually hyperparameters for that. Okay, and by the way, I'm gonna actually share with you guys all the scripts and everything that I use in this presentation. Thank you so much, and see you in next video. Thank you. Bye.